We will start shortly at 7 p.m. sharp, which is 4 p.m. in GMT and 7 p.m. in Baghdad time zone. Uh, 2 minutes, and we'll start with the presentation and everything. Just hope everyone will join us. Okay, just 1 second. Let me start sharing my screen with you and start the presentation to start with the MLOps. Okay, I hope my screen is shared with you and everything is okay. So I will start the presentation. And firstly, I would like to welcome you everyone in our third workshop in Bio and AI Baghdad. We held the three workshop. The first one, which was about a transformer under the hood of transformer network. And also then we make a workshop on deep reinforcement learning. And today topic is about MLOps journey in AWS. This is an event done by BioNAI Embedser. I am the Embedser of BioNAI Baghdad. In this event, we represent you the MLOps fundamentals, the mentality, the process, and some kind of what is about and what's related to. And then we will conclude with the lab on AWS. So without further ado, firstly, brief about me. I am Al-Mamun Rasool from Iraq. I am a software developer with 40 years of experience, also a machine learning engineer with 7 years of experience, and I am AWS certified machine learning specialist and also Google Cloud certified professional architect. Hold a master degree in computer vision, winning some kind of PyTorch competition by Facebook, and also I am AWS community builder. And also I want to say thanks to AWS community builder program for providing us with credit in AWS to do the lab without worrying about the balance in our AWS account. So without further ado, let's start by our presentation. Firstly, we want to know what is MLOps, and MLOps actually it's a culture. It's about people, technology, and a process. So it is not just the technology, it's not just the tools. It is some kind of culture that you will build around your team in your company to help mature and speed the process of productionizing your ML project. This culture is unifying the effort between the ML development, and I'm saying ML system development and an ML model. We'll know what the difference between ML system and ML model, and also ML system operation. In this, we are meaning that we are going to do automation and orchestration in this war. And also, we want to do many steps like monitoring and integration, testing, and all of this kind of stuff. They maybe you will see it from other kind of term that's called DevOps, but actually DevOps is something that not very fit in our case, and we will see in the next slide and then when we continue on the presentation, we will see why that DevOps is not it cannot be applied to MLOps. MLOps is different word and different kind of thing. Maybe you can call it extension to the MLOps. MLOps extension to DevOps. Now, if we want to start with, though, I want to start with the basic idea of ML project life cycle. This is maybe some of you will do different, but what this is the main phases that in any typical ML project. So you will start with the data collection and extraction. So what I mean by this is that there is maybe you are logging some kind of web click streams, and also for a visitor that is visiting this website and clicking in a specific kind of places, and maybe you want to predict whether they are going to go farther than your website, clicking other different kind of item and thing like this. So just saying that you are collecting the data, then you are when you're collecting the data, you will set some kind of data pipeline for it. And even if you don't have data pipeline, you will have to store it somewhere. So there the end of the job of data engineer then will become someone that who called himself a data scientist, who start to extract the data from this store. So maybe he will select some kind of historical data from data warehouses, or he will going to work with the data in the data lake or something like this. So there will be a data extraction. Then there will be some kind that when you extract the data, so you having a data, let's say you having data from database, from data warehouse, you will start with exploring this data, try to understand it and preparing it. So preparing the data is that you trying to do, maybe you're doing feature engineering on it, maybe you do some kind of a pre-processing on it, and you transform in some feature, you're dealing with some kind of missing data, or there is some kind of outlier that you want to handle it and things like this. So why I'm putting these to the exploration and preparation, because the more you understand the data, you understand it by explore it. The more you understand it, the more that you can prepare it, then you will analyze it and work on it. So this is the data phase. Then there is the phase of modeling. So there will come someone else that's working as a ML researcher, someone like this, who will take this data and work on it, train a model on it, and make some evaluation, validation. And then he finds that there is a good model and want to push it to production. Then he handle it for the ML engineer, the one that who will try to build a web service for this one and make it as a REST API or some kind of operational guy that he will came and set up some kind of monitoring tool and serving to provide this service to the end user. Let's say the end user will be a mobile application that will consume this API and will do the based on what the prediction, he will do some kind of action in the application. But this scenario, this stages is necessary and it's okay. But this scenario of many manual handoff between the team is something that's not mature. And because let's say that if you want to do the data extraction, you want to access a new data, maybe you go as a data scientist and asking the data engineer for permission to accessing the data that's come. Then now maybe this will come to some kind of security checks and things like this. This will delay you maybe a day, 2 days, or week, I don't know, but depend on the organization. Then while you're doing these things and you're exploring this data, now the one that's working on modeling, he's in isolated phase in here that he don't know which version of data that you was working on, which version of a feature that you have, what kind of a process that you made. This type of isolation of I will handle you and you will handle it to the next one. And also that when you pushing this model, when you push it, when you give it the SysOps, so that's when he put it in the production, the SysOps does not have any information about what is this black box it is and how to monitor it, what the metrics that he will look at. Any sysadmin, any SysOps will look about monitoring for and logs for the CPU utilization, memory utilization, like this, but he don't know what you need. Maybe there's some kind of degradation in your model prediction. So how he can deliver this thing to you? So this is one kind of bottleneck in this process. And this is why in the famous paper called the AI technical debate by Google, which is say that the more automation that you put in this process is the more the maturity level of your ML project will go. So you have to find your way to automate this thing. And I maybe ask something else. We want to orchestrate and automate this process, and also enabling traceability and visibility about the whole process. So if I am working on modeling here, I can understand which new data version that has come and what's happening inside here, and I can act from my side. I don't want to wait you to do something, because I have to have some kind of level of visibility about what's happening. And also I have to have a visibility about the monitoring and setting some kind of a criteria for myself. And also the one that's working in this side, maybe he want to have some kind of monitoring in new incoming data, and what's having to do some kind of schema checking, data drifting. Don't worry about this methodology. We will talk about it and tackle them one by one. So our main goal, if we want to say our main goal by this MLOps practices, is that we want to mature our ML project. And maturing this, and as I mentioned to you, that machine learning development lifecycle is very different than the traditional software development lifecycle, because there is a many of area that's here. As you can see, the data is here. That so it's not one factor which is in any software development lifecycle. It is just about the code and the change in algorithms. But we're having change in data, changing in the way that we process it and consume it, models and algorithms, the training model that is coming, its artifact, and also the code changes. Now, let's move on to see that why we need MLOps. Extra thing that we want to say, that the first thing that maybe when you're pushing your model to production, you will find some kind of degradation in model performance. So why this degradation? If we are serving a model which is static, it's already been trained. So let's take example to understand this thing. So maybe you have some kind of recommendation system that recommend a clothes based on trained in fashion. And now there is coming new season with the different fashions, with a different trend. Your model does not cover this thing, so it's hard to this model to recommend a better clothes trend to the new users that are seeking the new season trend and a new fashion on it. So you have to do some kind of retraining to this model. Because there is a new things, a new pattern that the model does not cover yet. And this is the main thing that the main question in many ML system, ML modeling, that when you build ML model, that you already know that your model will never gonna get a very generalized idea about all the patterns that it will came. It's only a training on a specific part of the data, try to generalize over it. And when you came with the data that contain pattern that as near to this pattern that is trained on, this model can predict, but the model cannot generalize over any unseen data, which is something that we are accepting it for this current stage. And it is a big question for those who work on research and how to build in a very generalized ML models. But for current stage is that because there is a new trend in the data, there is a new thing that's happened that we want to do retraining or re-architecturing to our model. There is a lot of things here that here in this case, there is a concept drift and data drift. And I will conclude on this and I will tell you what can happen and how we can fix it if we can, if possible. But we just want to move to get the basic here. Though we said that maybe your model performance will degrade. So its accuracy maybe will become lower by the time. And this is, you have to, but this is depend on. So the often that you have to retrain the model is depend on many cases. It's depend on the business cases, the value that is come, the type of application. So some kind of ML system, let's say that machine learning web application firewall, this kind of application that when a new attacks come, let's have to cover it and try to identify it. And there is many kind of attack that is coming day by day. So the frequency of the new pattern that will be affecting your model is what will let you to do a frequency of retraining or re-architecture in your model. Now, the other thing is that, as we mentioned before, a lot of manual steps that the hand off. So when the data engineering handing off to the data scientist maybe will handling off the process data to the machine learning researcher or machine learning engineer. And this manual handoff is something that will make the model development and deployment very slow process. And as you see, when we talk about software, when we have the DevOps, we have the DevOps for the continuous development and deployment for the software, because we want to keep up with the changes. Now, the same for MLOps, we want to keep up with the changes. We want to continually improve in our system and work. We want to reduce the time when we want to deploy a new model or develop a new one. And because the machine learning model is about some small part of the whole process, we want to take consideration about all the area. So as you can see, this is the main paper that the hidden technical debate in machine learning system that is mentioning, as I mentioned before, that the ML code, which is the one that we work a lot when we're doing researches, is considering as a small part of the whole process. So you are building a system. Why? This is why I'm saying when I talk about definitions, I'm talking about systems than models. So this model is consistency is something small on the whole process. We have a lot of things that we want to manage, and we want to integrate all part of this process to make the machine learning development life cycle consistent and speed up the deployment and development process, and also to react when there is some change happen and we want to cover it. Now, let's get back to get ourselves more comfortable. What is the difference between MLOps and DevOps? Because this is some kind of a questions that will came on your mind. Why another ops? Why are we talking about extra ops? If there is a DevOps, why we need MLOps? So I don't know if you get the idea from the beginning of the slide, but I will reiterate about it, and we will talk about it. And you will see there is something, and this is a logical approach to have a different area which called MLOps, because firstly that we talking that this is a culture. So when we focusing on our team, the team in ML project is actually the data scientists and ML researchers. Most of them, they does not came from software engineering or a production mentality. It is not a blaming, but is that this is the truth that this kind of work need a lot of experimental things. So the data researcher, the data scientists, the ML researchers, the main job and the main task is to focus on data exploration, working with data, building model, researching, finding new idea, but they are not considered about building mature production class code that is highly maintainable, reproducible, and coherent, and extra stuff that is they are not of them job. So this is one of the things that we want to consider. We are talking about different teams here. So this is the first thing, because we are talking different culture. Now, the second thing is the nature of ML. In machine learning, we are talking about experimental things. So if you take in your mind that if you are hearing about some kind of term in software engineering, some kind like that agility and some kind that sprinting and thinking ahead about a project, this kind of thing is hard to be done and reflected on the ML. In ML part, we are experimenting things, and in this experimenting things, it put us in many things that we need to manage this project differently. The other thing is that this is experimentally thing that there is a lot of experimental done under the hood. There has to be a way to track these experiments. So if we cannot track and understand this model is built based on these features and these features, what getting from this data version, If we cannot track this thing, we cannot track the experiment. If we does not maintain a good tracking system for the data versioning, feature versioning, model versioning, and artifact storing, and all the experiment that is done, we cannot reproduce this experiment. So if we want to hit retrain for the same experiment, we cannot get the same result, because if you get different data, different features, and of course extra thing like the seed and extra stuff. But we are talking here that there is one of a problem that we face in machine learning project. It is experimental and it's hard to track it. If we let the data scientists and machine learning do the tracking by themselves, they found themselves in a hard position. Maybe some of them will track it based on, but today there is a many of tools and libraries that help in doing this thing. But we are talking about without these tools, it's hard to be done. So the one of the other issues that we want to deal with is the experimental tracking. The other thing is that the testing in machine learning system is kind of different in when you're testing a software. The traditional software, we are talking about unit testing and XSF, but there here in machine learning system, there is a need to do testing based on the data itself. And we want to validate it, and we want to do model evaluation and validation. This is extra thing that is being added. So because we already have a code and now we have a model and data. This is the other thing is that we talk about is that reduce performance. We know that maybe it is not about the code, it's not about the algorithm, it is about the drifting in the data itself, and this we will cover it next. Now, we want to extend the DevOps mentality to MLOps mentality. I'm not talking that if you are a DevOps, you have to be a MLOps, but I'm saying that if we have these pipelines, that if we have this culture that's been built before us, that because we are part of company, we are part of a whole system, we are here to extend and to integrate with the others. So, but what make MLOps different? What extension we need to do to put in the DevOps pipelines so to make it catch up with our problem? The first thing is that the extension in the continuous integration part. Here in the extension that we want to add in the testing and validation, not just the code. We are talking about testing and validation, the data schema and models and all things around models and data. The other thing that we want to extend on is that we're talking about the continuous delivery. Now, when we continuous delivery in the software development is different kind, but what we're here in machine learning, that we are delivering a service, a package of ML system or ML that containing the first thing that we are containing a package of a training pipeline, which this has to be able to be hit a trigger to retrain the model if there's something that we want to retrain for a reason, of course. And also we are going to deliver an inference and a prediction service, which is different kind of code and artifact than those in the training. So we are expecting different container image for the training and different container image for the prediction service, and this will scale out depend on the cluster that we have. The extra thing that is being added, which is not extension, it is addition, that the continuous training. Now, the continuous training is that it just, you don't have to imagine it that you have to continuously retrain the model, whatever new data come now. This is different. Now, when you hit continuous training, you have to do it for, when you do retraining, you have to do it for a reason. But we're saying continuous training because we want it to be as a pipeline that have some kind of a trigger. So let's say that we have some kind of way or mechanism to catch if there is some kind of data drift. And when we facing this issue, of course, our model performance will be guarded. So what we are doing here, we're capturing new data, which is drifting from the main data. We are going to hit triggering the training pipeline to do retraining here. and this will gonna be automatically, or maybe you are going to ask some kind of putting human in the loop in this. But let's talking about the hitting retraining on automatic way. Then when you're doing this approach, there will be retraining, hitting the pipeline, and there will be must exporting or saving a model with its artifact and everything around it. And this model has to be ready. Now, this model has to be ready. Either it will be deployed automatically, or it has to wait for approval for checking for some kind of let's say a threshold of accuracy or extra kind of metrics. You can also put some kind of condition inside your pipeline saying if this model getting a threshold of 90% of accuracy, so replace the old one and push this new one with it. And maybe you will push it for a small portion of your user. This is approach that or scenario that you're going to take, but you at least have to have this kind of continuous training in your pipeline. Now there is extra thing that because you have in this this is in any operational thing, the continuous monitoring is the monitoring is something a crucial part in any operation. So because you cannot debug and work with around thing without knowing what's happening and when it's happening. But now when I'm talking continuous monitoring, I want the monitoring here to be from the beginning to the end of the process, and it's to be a loop process. It's continuous because I want to monitor the data for data drifting and extra thing, and if there is a new data and what's happened to schema checking and extra stuff, and also monitoring the pre-processing and what's happened from it, and you want to monitor the modeling and the training and retraining pipeline, and monitoring the prediction itself. I want to store some prediction that the model done for our live user, and then recheck it. Someone will come, some expert in domain will come and recheck what's happened to the model, if it's working properly or not, because this thing may be gonna go to very wrong places. Now, before I jump into some component of MLOps, because I want to highlight two things that we talk about. We want to automate the process, and we want to automate it and enable enabling traceability and visibility around it. And also we talk about that orchestration. So first thing that I want to touch a few things here. Because it's not covered on the slide. The first thing is that we want to lay out some kind of information that we need. The first thing is that the automation, if we get back to our life cycle of the machine learning system, the automation is meaning that these processes must be automated and reducing the handoff handling. So when we hit pre-processing and consume the data automatically, this will flow from side to side. But orchestration is something that's controlling the automation itself, so controlling these steps. So if we're reaching to modeling, there's some kind of orchestration saying that if the model accuracy is about 92%, then go ahead to production and deploy the model. If not, get back and get extra data and start the pre-processing and do extra stuff. So it's the way that we handle the steps, which step will be gonna done, and what will have to be done, and what the condition that has to be done. It is the orchestration of the whole process, while the automation is to automatically done the work that is being done by human and handle off in between them. This is the thing that I want to cover. The next thing is that when we're talking about traceability and visibility around, I want to cover very important thing is that when we have a model, that this model, I want to know that this model about which feature train and which data, because we have a raw data that's came in here, and there is a feature getting out from here that will go to model. Now we want to version the raw data. We want to have some kind of mechanism to have a version for this raw data, and we want to version the features that is being extracted because it's different. Maybe we have the raw data version 1, and we have a pre-process or a feature version 12. This is because this is depend on what we are doing here. And I want also to version the model. And I want, when I want to get this model, that model version 3, I want to know based on which feature it's trained, the version, based on which raw data that is being getting into this phase. And also there is extra stuff like this. Though this model is just not a model, it's a code that is the algorithm that it's training on. Maybe it was training on some kind of network, and we add an extra layer, extra hidden layer to it. This thing can happen. And so also I want to know which code that is related to. Not just this, I want to know what is the container image that was for this work. So all of this thing is around a thing that is very important, which is the model registry. So if we get back to our main components, the main thing for me is that I want to have in my MLOps project, I want to have a model registry, and I want also to have a feature store. I will talk about feature store next. And also I want to have a pipeline automation and orchestration. All of these things is important, and maybe you will see many extra things that in the future will coming. But the main component that you want to cover is that you want to have at least these three things: that you want a feature store, you want a model registry, and you want ML pipeline automation and orchestration. Now we know what is automation, and it's important and how to orchestrate it, and we know the model registry. If we want to talk about feature stores, is that it's some kind of that it is a single source of truth that you will consume. Let me give you example so you can have some kind of solid understanding of it. So you have many work, maybe many of you have working on different kind of a machine learning project, and you starting by doing a pre-processing for the data, and you extracting the feature because this is the core thing of your work. This feature will be used in your ML algorithm to train the model on. Now, when you want your colleague to work with you, your colleague will have to redo the pre-processing stages to get the same features. But why we don't have a way that we can share the features? So let's say Ahmed was a data scientist doing the pre-processing stages, and he want to share the feature, not the data, not the pre-processing code. He want to share the feature to Isam, and this, we need this feature store. Not just this, we need to versioning the features that is being done. We need to control the steps that is being taken to build this feature store. So maybe we will join extra feature on our way going, and maybe if we have a 3 steps that doing the feature store. Let's say this example, that I have a raw data, and I have a step 1 which will handle the missing data. Then I have a step 2 which will do feature scaling. Now, let's say if I start by feature scaling and then now handling the missing data, maybe I have some kind of problem in my data. So what I decided that I want to flip this process, because this is not appropriate way that to do. So I have to get back to this thing. Do I have to rechange my code to do this thing stuff, or do I have to redo the work again? So why I don't have some kind of pipeline or mature thing that to do the, and this is the feature store. And you will see next, if we go into the lab, I have a lab on pipeline, but I will also do a lab for you about data wrangler in AWS and feature store, so you can see how easily this steps been done and can be flipped and joined and on the way on a very beautiful UI. So we want to say that the most core component that you have to put in your mind in your ML foundation, that there has to be model registry, there has to be feature store, and there has to be ML pipeline orchestrator. Then when you're doing the pipeline automation orchestration, then you will find that you have to have some kind of monitoring, some kind of data drifting checking, and extra stuff to be done. And we will talk about all of these things. Now, because this is workshop about AWS, we want to look at something called AWS SageMaker. Inside AWS SageMaker, there is a lot of services that will help us going from stage to stage as we're talking. So this is some kind of simple element in the AWS SageMaker, but it's cover all the process that we need inside our MLOps work. So the first thing is that you have to put in mind, we mentioned that before, if I want to accessing the data as a data scientist, and I want to access the data, I will ask the data engineer to add me or doing some kind of security checkers. Now, if we doing some kind of data lake, which is governed by some kind of policies, and we just adding those who can access the data and which version of data will be, we will also can know the data cataloging and knowing which one accesses which specific kind of data and activity and extra stuff. So here we're putting some kind of cataloging and putting data in data lake and governing it. And also it can help to do data governing and regulation and extra stuff that is being done here. Now, then we will entering that there is some kind of data lake here that's containing the data, its catalog and everything related to it. And it's governed by some kind of access right and policy and things like this. Now, we will enter the stage of MLOps. So here the life cycle of ML system that we have. So if we having these pipelines that we want to automate, there is some kind of called AWS SageMaker pipeline. Now, these pipelines is what gonna help us automate and orchestrate the data preparation, experiment, training, and tuning. And this is actually the main job for AWS SageMaker pipeline. Also, we are going to have AWS SageMaker model registry. And here in the model registry, as I mentioned to you, that you will have a version for your model and metadata, metric, and approval. So what we meaning by this? So we having a version for our candidate, our models, and this version containing metadata regarding which input data, which version of feature that's been used, in which script then be done by, and which container image, and also metrics that we that while the trained model was done, let's say the evaluation metrics, what the accuracy, or what is the AUC that's been reported by the model. And also we have some kind of that, do we need to approve about this model? Do you want to push it to production so you can approve on the model and the model will go out to production? And maybe you reject it, so this model will get out from the possible candidate that you want to push. Now, also the project that you can enable in CI/CD on it, so you can enabling the integration of the code, model, and data. And also the most important part, I was saying that you have to have a full visibility and traceability, that you have model monitor. And now here, this is in model monitor. There is a lot of things that will be done for you. So in model monitor, it's not just the monitoring the model itself. There is a monitor for the data, for the drifting, thing like this. When I mentioned to you that you have to have an automations and work and orchestration. Now, when you're doing orchestration, that there is some kind of gates, and let's name it a quality gate. So what's this gate? So new data has come. Do I have to get it in to do pre-processing? No, of course not. I will have to do schema checking. Why? Maybe I found out that if we're talking about CCTV cameras, and there is some not just cameras, any sensors that is have some problem when it's sending data, so it's sending as a corrupted data. So we have to validate this as an input. And also maybe that we are expecting a categorical data in column A, and now we getting some weird integer data. There is a problem with the data that we are feeding to us. So we're doing some kind of schema checking and data validation. This is one of the cases. The other cases is that the data drift. So what is the data drift? I'm talking about data drift. I will explain it now. So what is the data drift? So first thing, that there is some kind of code that's saying that constant change is the only constant in the life. So we know that everything can change, and so for data. So let's get some idea about what's happened. If there is a change happen in your data, a statistical change that happened, what kind of statistical change? I give you the example of that. If you have some kind of a recommender system, and this recommender system, let's get it to different one, we recommending movies to you, and now there is a new genre, a new thing that's happened in the world. We recommending, my model that I built was about 2 years ago, and then this in next to new 2 years that's containing a lot of things to be considered when you giving a recommender system. So you have to retrain the model. Let's get it back to a different thing, that is um the data that is coming to us, how I can check if I have a drift on it. So the data what's the drift in the data is that it is statistical drift that will make our model a performance or accuracy matrices to get degraded. So its performance will lower over the time. So if we can monitor the performance by the end, so if we can monitor its prediction, and we have some kind of grounded truth, this will be very okay. But this is not all the cases, that we don't have always the grounded truth for the prediction, because only we have it while we're training on the train and test and validation data, but we don't have it for yet for the prediction data. So what we can do, one of the methods or the main theme of this method is to take a baseline data, your main data, and calculate some kind of statistical information about the data, and a statistical information about each feature in the data. And now then, when a new data come, there will be the same calculation on the new data, and then will be some kind of calculating the difference. So how much this data is deviation or different from the data we have from our baseline data. And based on this, how large we have, we can set some kind of a threshold that's saying, if we have some kind of this threshold, please send a notification to the scientists and the ML researcher to check out what's happened, or maybe hitting a retraining on this, because maybe there is a new thing that's happened. Let me give you an example. Now, we're building some kind of regression model that's doing a predicting the price of the houses, and accepting that these prices of houses will be in million of dollars. Let's say this thing, just keep it in your mind, or thousands of dollars. Let's say the house prices ranges from $300,000 to or 20 million. Now there is some kind of economic thing that's happened in the salary, and the income has been in very lower state here. And so also this state and this thing will affect with the economy. So now the house that was worth $300,000 now will worth $13,000. So your model is way very far from what's in the real life. Now, how this thing changes happen, that we may be adding some kind of feature regarding the main and max salary in this country, and the income, and I don't know about other extra economic thing that we may take into consideration. But because we taking this in our consideration, we need to see that the min and the maximum value that is came into our new data has been different. So what we are considering as the average salary, which was maybe said about 300,000, now it's become $13,000, and this is something weird can happen. And if we are not monitoring this, we cannot say or judge about our model if it's working or not, because it will give a prediction no matter what will happen. And because of this, and because it will give us these predictions, Now, what we are going to do is that the first thing is that we want to monitor our baseline. As I mentioned before, is that we having some kind of statistical information about the baseline data and statistical information collected for the new data. And if they are deviated, if there is very different in its statistical information, now we have to have some kind of action to be done. The action depend on your main architecting for the project, but we are sticking that we have to have this monitor. Now we have two cases: that the error, which is we validating the schema and the input, and the data drifting. But there is extra thing which is called the concept drift. What it is now, in our data drift, what's happening is that the relation between X and Y is still stable. So when I give you information about the house, about how many rooms in the house, the geographical area of the house, and extra stuff, you're going to give me some kind of a prediction. It's okay. And this relation is still the same. So X is Y is depending on X, and when I give you X, you will predict in Y, and this okay. But there is something that's happening that's changing the scale of a prediction, or a new trend you have to come up with. As we're talking about trend in our recommender system about the closed system. Now, what's happened if the relation between X and Y is not working anymore? So what it is? Let me give you example. Let's say that you have a web application firewall. This is based on ML system. So it's analyzing the traffic and judging if this is if this some kind of new ransomware attack, or some kind of a new attack that DDoS attack or thing like this, but or some kind of a new web attack. Let's say there is a new trend of web attacks or new trend of attacks that's coming that is different than the previous. So the system has been trained on detecting a SQL injection attack and file inclusion and file upload attack, but this is not trained on some kind of the attack that is doing command execution. So now when this attack has come, the system cannot detect it, and it is not statistical information different. It is that the relation between X and Y it is different. So this pattern is very different than the pattern that is the model trained on. It's very different. It's a new pattern. So here we need maybe to re-architect the model. Maybe we need to add extra thing to the model, not just retraining. And this is called the concept drift. And this is the relation between the model and the data, and between the X and Y is going different ways. And so this is the thing that you put in your mind, that if there is an error in the data, and if there is a data drift or concept drift, this is the main thing that we have covered yet. So I think here that we can conclude on these things, and we talk about many stuff regarding MLOps. We talk about why we need MLOps and things like this. Maybe it's time now to do our lab. Let me start by it. Okay. So I'm here in AWS. Let me get you into this. Now you just have to go to Amazon SageMaker. And now you can go to AWS SageMaker Studio. You have to hit Studio. Now it's going to take us to our SageMaker Studio, which is some kind of framework that can help us managing our project and managing the system that we're working on. Okay. As you can see, it will open as open a Jupyter server for us, and this is the Telegram. Quit. Okay. This is the main view for AWS SageMaker, and I will start get you to the AWS SageMaker project. And if you want to check this, there is a lot of things inside that you have model registry, you have the experiment and trail, which is related to AutoML that has been done for. And by the way, the AutoML by AWS is very helpful. That is not just generate for you the code and everything. It's training code and Jupyter File and extra stuff, which is outside of a project, and you want to create a new one. The main helpful thing in AWS that is give you some kind of template that you can start with. And this template is very helpful. This template that we are going to use this template. You can use it, adjust it, and do it as you want in your work in while you're working on your MLOps project. But all of this work is you will get to get the whole concept, practice it, and use it. And the thing why I'm using AWS SageMaker, let me tell you something, that we are talking about mature machine learning project management. And if you are not relying on a mature process, on a mature systems, and sitting on the shoulder of the giants, your life will be hard because you are going to have to manage a lot of things. And now we'll see how this is easy to be managed. Let's start by selecting this and start doing the project. It is just that we want to give it a project name and want to move on. By the way, while we are working here, if anyone have some kind of a question, I think there is some kind of thing that will be done while we're doing this thing. It will be creating the project for us. It will take some kind of time, and we will see the pipeline start working. Yeah. Just initializing the project to create it for us, and just we have to wait, and then we will go to the next stages of what we are going to do in this train, pre-process, and deploy. We are going to see the ML pipelines and how it's been visualized, and the model registry, the steps, and the conditions, and like this. I don't know if someone have a question, he want to raise his hand. So while we are working on this phase, Ammar, if you want to open your mic, no. We are just waiting the project to be done. I don't want to mess up with other project that has been working. You just have to wait a few minutes. Also, I can show you extra thing while we're working on this project. I can work on, let me show you something that we talk about feature stores and data flow. It is extra lab, which is that because we are waiting. Now, oh yes, okay, that's good. Let me clone this repo. This is the repo that's been taken for the example, which is already public in by AWS. Let's clone this one also. Okay. Let me show you what this project is. You can also start your own template. It's not something that you just have to use AWS project, but we are wanting to go in this is the pipeline. Now, this is the pipeline that you can see the visualization of the pipeline itself. The pipeline has been written as a code, and I will show you the code for it lately, but we just want to see a graph to see what the pipeline that's been building for us. This is stages that I can zoom in. Just the internet is so bad. Okay. This is the steps that is being done, which is been written as a code, and I will show you the code later. But I just want you to see this is what we're talking about. We want to have an automated pipeline with orchestration. Now, this pipeline, there is a pre-processing for the data that will going to go to extra steps. So it's going to go to training, and there is some kind of conditions, and there is evaluation. As you can see here, while we're doing checking here, there is a condition. If it's true, it will register the model. And if it's not above this threshold, it will not register it. So this kind of, this pipeline is building by you putting the steps you want, and we will check the code for it. And if you hit in here for the parameters, which is what's happening here, is that they input data URL, and the approval of the, I said that there we have to have some kind of model approval. Now we have a model approval, a manual approval. Now, while we are training on this machine, MLM5X large. How much a processing instant count? We have one. And what is the instant count? What the pre-processing instant, which is MLM5X large. Now, this when it's done we will see it. But let's jump back and to see some kind of the code itself that we are working on. Let me show you the pipeline in the code. Let me show you. This is the definition of the pipeline itself. So what is this definition? It's we're gonna to get the pipeline from the argument and add it in to do it, but we can see that and this is the file that has been doing the job for us. This is the pre-processing file. As I told you, this is the steps. So if you're working with this AWS SageMaker, you already know that how to send a pre-processing script that will be launched on a container to do the pre-processing and the modeling script and extra stuff. So let's see what is these things. Now, this is the pre-processing. This is the evaluation while the pipeline is here. So if we want to start study data from here, and let me show it to you. I don't know if you can see it, but I'm zooming it so I can see it. Now this is the pipeline definition itself. This is a parameter. Just we will gonna to hit above. Just we want to know how the pipeline is being written. So simply, this is the code that you're writing a pipeline, but each one of these thing is a simple API call. So this is the pipeline. We taking that. We want the instant type. We want the instant count. We want the training instant type. We want the model approval status and the input data. And this is the steps, how it's been logically coordinated. Step, train. So we're doing processing, then we do train, then we do evaluation, then we have a condition step. So this is how we define it. Now, how each step is being defined, we can get back here. Let's get back to it one by one. Okay. This is just simply that we saying which kind of instant type, and this is the main parameter. But now for each step, for the processing step, it is about a scaling processor. Here we're taking the pre-processing will be run on a scale-learn container image that already built by AWS SageMaker. So you are not shipping any container file or thing like this, and you are not shipping any ECR Elastic Container Registry. This is already registered inside AWS. What this is? This is a scale-learn processor. So it's already contain a scikit-learn library pre-installed, and what we are going to ship inside it. Just the name, we are doing that. What we want, this is the processing output. We want it to output train, validation, and test. It is the pre-processing script, which is this one. And we give it the input data, and as you see that the input data is been above here, that we have the input data as an argument. We can expect it as an argument, and it is okay. Now also, this is for here, this is the processing step. So we just define the processing step. We know this is a scale-learn container image, and it will run this pre-processing script. Oh, by the way, if you want to look up, this is the pre-processing script. But just normally that we are taking the data types in, and we doing calculation around it. We changing the data, transforming categorical data, doing pre-processing. Just you can write your own script, just the pandas or whatever you want, and it's already containing the library that you want, the scalar, symbol, imputer. All of the scalar itself is it's been installed for you on this container image, and you can taking the all of the argument from running the container. Let's get back. Now, for the model, where we want to store the model after training, this the place that we set in it, and the image URI. What is the image URI? Is I'll say that this is the container image. Now this is the container image for the training that we will do. It is XGBoost, and I just told you that there is a lot of things that AWS do for you. Now you have to see that we getting a pre-made XGBoost container image by AWS itself, and we take in this image URI, we add it to our training, and we take in all the other information like the instant type, which is already defined. This is the training instant type, and the path that we want to store the model on, and also where we're gonna go to get the data. Now we set some kind of hyperparameter that you know that you have to set these hyperparameters for your XGBoost or any kind of model that you're training. You have to set max depth, number of stuff that you're doing. All of this thing is simply that you already know it when you're building XGBoost. Now the step of the training is actually what is that we having this estimator, we have the input, the type of the input, the location of the input and the type, and there is a validation. This is the validation channel, and here that we have our training step. As you can see, that you have a training step containing the train and the validation, and it's containing the estimator. And XGBoost training estimator, it's containing the image URI and the model path, that where we're going to store the model after training. Now we have the evaluation, and also it will take the image URI and we are going to do evaluation based on this. The thing that you say is that we have a step for evaluation, but the main let me show you that they're here we have in the model registry is that what will gonna happen based on the condition, of course. But based what is the model registry here? It will take the estimator, it will expect it to output the model, and it's going to have this model artifact, and it will store it for us. And what the inference instance, so if we deploy it, what kind of inference instance that we're going to deploy on, and the transformation instance that's done above, and the package name and the approval status, and we say this is a manual approval status. And then we have, this is the main thing, which is, if you can see, this is very beautiful thing, that you have a condition, as you're seeing here, that we set in a condition step, and this condition step will decide what's happened if it's kind of true. So the condition is saying that less than or equal to, and you're setting the left and the right. So the left side of the equation is that you get from the evaluation step, you get the regression metrics, the mean square error value, and you get these threshold. And if it is listed than equal, the step condition, the condition if step, if the steps is done correctly, so you have the if step, the registration of the model, and you have else, which is here is not defined for us. Maybe you can do extra stuff to do. And all of these things, if you get back here, let me start the execution. Sorry. And as you can see here, all of these steps, as is defined here in the pipeline.py. And this is the final condition, which is here. And we can see in the details of our execution, I started the execution. It's a start by processing. All the output of the processing is being get for us, the output, the log, the information. When it's done, all of this information will be registered. I'm sorry, I'm zooming very in here because I can't see. Now, when this happens, it will get to this next stage and extra step. So this step will be run one after one, and will be done and complete, and we will have a model that has been registered. And if you get back to the project, there is a model group, and that if the training is being done, that we will going to have a model that is bending. But currently, that, as you can see, that it's asking me, do I have to reject, approve, or let it in the bending? So it's depend on what I am seeing in the model itself. So I can see what's happened to the model. There is a report, if there is a quality. So this is the metric value, the standard deviation. This is the metric value, how much it's getting. And I can check these things and decide the model if I want to prove it. So if I want to prove the model, it's gonna hit to deployment, and it's going to go to the as a let's say it's going to be registered in the endpoint. And you can back to my project. As you can see here, I have model registry, all the model that is registered, and it's saying that if I want to create model group version for it, and also I have an endpoint, and as you can see, this is the endpoint about the model that we already give approval for, and we don't have any income yet coming to here. So as you can see that the pipeline that we done, based on condition. As you see, as simple as writing this code is to orchestrate the pipeline and give it some kind of conditions, and we doing model registry. But under the hood, there is the model has been registered and there is approval. There is a lot of thing that is under this menu, as you can see in here. And also that if you back to your studio, if you hit your project, you can see that this is the main project. If you lost yourself on these tabs, let me get back to you here. Under very user friendly UI, that you have all your project, and you have the project, you have the pipeline on it, and this pipeline is already executed in success, and we can track it. So this is the input. As I told you, I have to know the input. I have to know the output, what's happening. As we see, this is the 3 channels that's been registered. If there is a log about something that's happened, and I want to see it, to check it, extra information about itself, how much is the running time. Then we have the training the model. We know the input that is coming. We want to take the output. It is the training root mean square error 1.7, while its validation root mean square error 2.2, and the model is registered under this directory. So as you can see, that everything is trackable and everything is constant. And the logs, what's happening, and all of this is the log while the model was training. And this is the extra information that was about it. Now that we have this evaluation, and as you can see, and then we have this condition. So it's output true because it's already been above the threshold itself. And this is the registration, and we have the model that is registered. So it can help us that this model with this artifact, it's root mean square error when we already see it, when we want to approve it, and we approve the model itself, and I get back to these stages. Now with this, I can conclude the workshop, and I want to stop live sharing. And if anyone have a question, you are free to ask. Just you can raise your hand, and I can see you, so I can answer your question. If anyone have a question, I can unmute you, or you can write in the chat. I don't know if someone have a question regarding this, or you want me to get back to something, you just can raise your hand on it. Also, while if someone want to ask, I will send also the link for the certification, which is automatically will send you the certification when you, because we have completed the workshop, and I hope you enjoy it. And also I am waiting your question. I'm not going anywhere until if you have some question here. I'm just also going to check if there is a questions inside the Facebook, because we are already live on Facebook. And let me send you the link. Yes, who have a question? Ammar, can you see who have raised his hand? Just we can unmute him. This is the link for attending certification. If you want to, you can just register on it. I sent it in the chat. I think there's someone has raising his hand and it's not here. If you want to check. Okay. I don't see any question in the chat, and I don't see any question in the Facebook. Okay. So to conclude here, uh, we have reaching the end of the workshop. We have seeing how the fundamentals of MLOps, what it is, and the main framework that we want to work on. Also, there is a lot of things that we can work on in AWS SageMaker. It is not just about this pipeline and management. There is a lot of things that we can done. There is model monitoring, there is feature store and data wrangler, and a lot of things that cannot be covered in one workshop. So it is just simple idea to get you in the mood of ML ops and to know it is not just about technology, it's about technology, people, and process. And I hope you enjoy in the workshop, and maybe in the next workshops we will go deeper, maybe taking a specific part and working on it, just like working on just on feature store and know how it's working and doing it, or maybe working on different kind of extra stuff. I hope you enjoy it, and keep watching your our chat, because I send you the link of the certification, so you can just hit the link, put on your name, because I will close the form in the next day, so you can just use the link in the chat and go and take your certification for attending this workshop. And thank you everyone for your patience. Thank you everyone for listening to me, and hope to see you in next workshops. And if you have some kind of recommendation for the workshops titles or what it has to be, you can just simply go to our group on Facebook. If you don't have the group, I will send it to you here in the chat, so you can reach out the group and recommend any kind of workshop that you want in machine learning and in data science. And especially I will be very welcoming anything regarding the ops and operationalizing the machine learning project. Here is the link of the group. And thank you again, and hope to see you in the coming workshops. Bye bye.